So today's warm-up, just some basic multiplication. Hopefully the first two you should be able to do in your head. They're the basic multiplication facts. The other two you might need the calculator for. 10 times 10, 100. 12 times 12, 144. 14 times 14 is 196. And 17 times 7 is 289. We're going to be looking over the next 2 days at square roots. Today we're going to be doing basic square roots that come out even, square root equations. And then the second day we're going to work on what happens if my square root's going to give me a decimal. How do I work with it at that point? So we're going to start with a chart. I'm going to fill the whole chart in, but I'm really going to focus on the first two rows. So we're going to take 1, we're going to plug 1 in the calculator and square it. 1 squared is 1. We take the answer from the middle column and square root that answer, and you happen to get 1 again. 1 isn't a really good one to see the pattern, but we kind of need it. 2 squared is 4. Take the square root of the middle number, so 4, and the square root of 4 is 2. You should notice that I'm ending up back where I started. So I'm going to go in, I'm going to fill in the rest of the chart. 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, 49, 64, 81, 100, 121, 144. The square root of 144 gets me back to 12. The square root of 100 gets me, square root of 121. The square root of 121 gets me back to 11. The square root of 100 gets me back to 10. Square root of 81 gives me 9. Square root of 64 gives me 8. Square root of 49 gives me 7. Square root of 36 gives me 6. Square root of 25 gives me 5. Square root of 16 gives me 4. And the square root of 9 gives me 3. So I'm ending up back where I started. This list in the middle, though, this is So the center list I circled is a list of perfect squares. These are the numbers that when you take the square root of them, they're going to work out evenly. You are expected to know this list by memorization up through 100. So when I ask you for a list of perfect squares, you should be able to give me this list. And when I ask you for the square root of these numbers, you should be able to give them to me. If I say what's the square root of 36, you need to be able to go 6. Basically, it's what number times itself got me 36. What number times itself gives me 49? And that's 7. So the square root of 49 is 7. The square root of 9 is 3, because 3 times 3 is 9. That's how you get your list of perfect squares, and that's also how you take the square root of them. Thinking about what number times itself gives me that number. So now, here we go, down through a few perfect squares. Square root of 16 is 4. Square root of 64 is 8. Square root of 144 is 12. You're not expected to know this one, but the square root of 256 is 16. You would plug that one into the calculator. Okay? And the definition of a perfect square, the formal definition is down at the bottom. A number that is the square of an integer. So if I take a number and multiply it by itself, that's the same thing as squaring, I end up with a perfect square. So now we're going to do some approximating of square roots. You're going to be wanting to look at that chart that we made of those perfect squares. So sometimes square roots you can't get a whole number answer. You're going to get a decimal. So before we actually jump into the decimals and what they are and how we're going to find them, we're going to approximate to the nearest whole number without the use of our calculator. What you want to do is we're going to start with the first one, square root of 51. What two perfect squares does 51 fall in between? Well, 51 falls in between 49 and 64. 51 is closer to 49, and the square root of 49 is 7. So we say that 51 is approximately 7. Let's look at the second one, the square root of 125. The square root of 125 is going to fall in between the square root of 121 and 144. It's obviously closer to 121, so it's approximately 11. Square root of 10 falls in between the square root of 9 and the square root of 16. Closer to 9, so we're going to go with approximately the square root of 3. Now the square root of 151, that falls in between our perfect square of 144 and 151, and then 13 times 13 is 169. From 144 to 157, I jumped 7 spaces. To go from 151 to 169, I'm going to be jumping 18 spaces, so I'm closer to 144. So it's approximately this 12. Looking at evaluating some expressions, basically you're going to plug A and B in. A square root symbol works just like parentheses. You have to do everything underneath the square root symbol first, and one of the very last steps you should be doing is actually taking the square root. So the square root of 12 plus 4 gives me the square root of 16, and the square root of 16 is 4. Square root of 4 squared minus 12. Exponents first. Square root of 16 minus 12. 4 squared is 16. 16 minus 12 is the square root of 4, and we know that the square root of 4 is 2. 3. Square root of 12 times 4 plus 1. So that's 3 times the square root of 48 plus 1. 3 times the square root of 49. Square root of 49 is 7. And that 3 out front is being multiplied. So 3 times 7 is 21. Go ahead, try these 4 on your own. And then once you have them, we'll come back and go over them. So this one is the square root of 48 minus 12, which is the square root of 36, which is 6 for the first one. Second one, square root of 48 plus 12 plus 4. That's the square root of 64, which is 8. Negative 3 times the square root of 48 times 12. That's negative 3 times the square root of 576. You'd obviously need to do that one in the calculator. That's negative 3 times 24, which is negative 72. Square root of 12 squared minus 48 plus 15. That's the square root of 144 minus 63, which is the square root of 81, which will give you 9. Last example for today, we need to look at some square root equations. So in the first one, I have a squared equaling 9. Some number squared gave me 9. Just like when we were doing equations before, to undo addition, we use subtraction. To undo multiplication, we use division. To undo squaring something, we're going to square root both sides. So I'm going to square root a squared, and I'm going to square root 9. The square root symbol and the squared symbol cancel each other out, leaving me with a. The square root of 9, you should know, is 3. With equations, though, you have to put this positive negative symbol in the front because we actually don't know if A was positive 3 or if A was negative 3. Could have been either one because 3 times 3 gives me 9, but also negative 3 times negative 3 also gives me negative 9. So I have to account for both of them. Only when you have equations do you have to write that positive negative in there. Second one, square root of x, square root of 361. The 2 and the square root symbol cancel each other out. And I get positive or negative 19 equaling x. 3. 5y squared equals 110. Have to get rid of the 5 first. 5 is being multiplied. To get rid of it, I'm going to divide each side by 5. And I get y squared equaling 22. Square root each side. Round to the nearest tenths place. And I get positive and negative 4.7. Here's 3 for you to try. They're just like the other ones. For number 4, I'm going to square root each side, and x is positive or negative 7. Even if you can do them in your head, I expect to see the square root symbol to show me that you realize they do cancel out. So the square root of 441 and the square root of t squared, positive or negative 21 equals t. You can write this as t equals positive or negative 21. It makes no difference how you write your answer. Number 6, divide each side by 16 first. You end up with 12.5 equaling t squared. Square root each side, and I get positive. My positive symbols are looking bad. I get positive and negative 3.5 equaling t. It's okay to square root a decimal, and it just so happens that it gave us another decimal. There's nothing wrong with that. So that's it for the first part of the lesson. It is a worksheet tonight for your homework. Hopefully you have that in front of you. If you do not, you should be able to access it from my webpage. So for the warm-up today, you just have a list of perfect squares, and I'm asking you to find the square root. So the square root of 64 is 8, 6, 7, 11, 9, and the square root of negative 9. It's actually no solution. You cannot take the square root of a negative number without doing a whole lot of other funky stuff and using imaginary values. We won't talk about it. You'll talk about imaginary values when you get to Algebra 2. So for right now, for our purposes, the square root of a negative at any point is no solution. So today we're looking at what happens. I didn't want to do that. The last vocab word is cube root. It seems to have gotten cut off a little bit. What we're looking at today is how do we estimate things to the nearest tenths place. And this is estimating without the use of a calculator. Okay, so we're going to be estimating without the use of a calculator. I know, sounds like a lot of fun. Here we go. I want to estimate the value of the square root of 5 to the nearest tenth place. So I'm going one number past the decimal point. If you remember from yesterday when we did it to the nearest whole number, we picked the perfect square that fit on each side. So on one side of the square root of 5, I have the square root of 4. On the other side of the square root of 5, I have the square root of 9. Okay, those are the perfect squares on either side. What you want to do now is you want to determine which one 5 is closer to. Is 5 closer to 4, or is 5 closer to 9? In this case, the 5 is closer to 4. No matter which number it's closer to, no matter what, Step 1 is take the square root of lowest perfect square. So that would be the square root of 4, which is 2. 2 is going to be our starting point, and we're just going to make a list. We're going to start with 2.1, and we're going to square it. Because remember, some number squared gave us 5. We're going to do 2.2, and we're going to square it. We're going to do 2.3, and we're going to square it. So 2.1 squared gives me 4.41. 2.2 squared gives me 4.84. You're using your calculator for this. 2.3 squared gives me 5.29. Well, it can't be 2.3 because that went over 5. So the one that's closest to 5 without going over is 2.2. So we say the square root of 5 is approximately 2.2. Once you get 2.2, that 4.84, even though it looks really close to 5, you have to go until you find the first one that goes over the value you're looking for. 2.3 went over 5. So I knew the one right below that had to be my answer. Square root of 14. Square root of 14 fits between 9 and the square root of 16. 14 is closer to 16, but I'm going to start with the square root of 9. Square root of 9 is 3. If you don't want to start at 3.1, another good place to start is actually to start at 3.5. To always just start at 3.5 squared. So 3.5 squared is 12.25. Well, I'm not close to 14 yet. So there's no point in me doing 3.4 squared, 3.3 squared. There's no point in that. From 3.5, I obviously need to go higher. So we're going to do 3.6 squared, and I get 12.96. I'm going to do 3.7 squared. I'm going to get 13.69. I'm going to do 3.8 squared. I'm going to get 14.44. 14.44, that's the first time that I've gone over 14. So therefore my answer has to be the one right below that, or the 3.7. 34 is in between the square root of 25 and the square root of 36. Start by taking the square root of the lowest value, which is 25, and that gives me 5. Always start at the point 5. 5.5 squared is 30.3. I need to get to 34. 5.6 squared is 31.4. 5.7 squared is 32.5. 5.8 squared is 33.6. 5.9 squared is 34.8. If you have to go to the next one, if 5.9 doesn't work, the next one is 6. And the square root 6 squared gives me 36. So if I get the whole way to 6 and I haven't found one that works yet, then I know I did something wrong because I shouldn't be the whole way up to my other end yet. That's the point of having that 36 there, to kind of put that upper boundary. But if you did notice as we were going through, the 34.8 or the 5.9 squared was the first one that went over. So 5.8 is going to be our answer for the square root of 34. I have 6 of these for you to try. You're going to want to make sure you leave yourself a lot of room because you're going to need to make sure that you have room to make the charts and have room to work. This is not something you want to try to cram into a little space. So the square root of 89, when you estimated it, you should get 9.4. Square root of 46 should be close to 6.7. Square root of 2 is close to 1.4. Square root of 17 is approximately 4.1. Square root of 50. The actual closest estimate is 7, because when you do 7.1, you get 50.4, which is over. So 7.1 squared is 50.4. So the actual closest estimate is 7.0 exactly. And it should make sense because the square root of 49 is just slightly below the square root of 50. So the 7 is actually our answer there. And the square root of 15 is going to give me roughly 3.8. Looking at some application problems. The area of a square is 26 square feet. It's important that we realize that this is the area of a square. So the area of a square is 26 square feet. So my total is 26. To find the area of a square, it's length times width, but all of my sides are the same, so that would be x squared. So just like we did yesterday, we're going to square root each side. But the square root of 26 isn't going to come out nice and neat. You have to do the estimating. And when you make your chart and you estimate, you find out that the square root of 26 is close to 5.1 and 5.1 feet, because you do need a label. The length of one side of a right triangle is the square root of 8. Estimate the length of this side to the nearest tens place. So we don't even have to really figure much out. They already told us that they want us to do the square root of 8. The square root of 8 falls in between the square root of 4 and the square root of 9. And 2.8. 2.8 inches is the closest estimate for the square root of 8. Your homework tonight, hopefully you have it in front of you. If you don't, you should be able to get it from my website. It's going to take a while tonight. You have to make the charts, but we have to continue to get into this practice. Okay, we have to keep working our way through this.